The next step in the hand mixer demonstration is to take a look at synchronous design and also simulation. Now what we've done is we've opened up the hand mixer, and you can see that we have the body actually completed. And in fact we have some display configurations just to turn off the other components so that you can appreciate some of the features, plastic part type features that we've added to the top of the body. And we've also got a display configuration for the handle, and you can see the switch where the wires will go, and that's something that we'll take a look at a little bit later. And then of course for this particular demonstration we want to turn on the mixer bottom. So what I'm going to do is I'm going to go over to the part library, and we have what we need to do is you make sure that we want to go to our working folder, and you'll notice that there's a motor assembly, and the motor assembly is what we want to bring into this part and place some assembly relationships. Now automatically when we bring components in to the assembly, it puts us in the assemble command, which allows us to place relationships. So I'm going to grab this bottom plane and just start placing these parts into their position, two alignments and a mate, and you'll notice that it locks it in and it turns it to its natural colors when it's fully positioned. The next thing that we want to do is go ahead and in-place activate into the motor assembly, where we're going to actually design this back frame bracket. And you can see that the back frame is already been created, so let's go ahead and in-place activate into the back frame. And we've just started actually modeling it by just creating the sketch for it. And if I turn on the background, you'll see kind of how it fits into the design. And of course we're going to need to make some adjustments, so let's go ahead and get started on that. So what I'm going to do is go ahead and turn off the background components, and I'm just going to add a couple of dimensions. So let's add a dimension on this end, and of course we want to be able to adjust the length of this, and we can kind of see what the dimension on this side is. We might want to make a change there so that they're equal. But at this point let's just go ahead and grab the region and pull it down, and you'll notice we can either scroll the mouse or just pull it down and click, or we can key in an accurate dimension. In this case we want 18 millimeters. Now once that's done, I'll point out that the 2D sketches that were created on that profile were converted to driving PMI dimensions. As an example, I can take the 28, and if I want to make a change to it, you'll notice I can scroll that value. But in this case, let's go ahead and make it 32. And then you'll notice here that I have 5 millimeters on one side, so let's go ahead and change our value on this side, and we'll probably want to make it 5 millimeters, so I'll go ahead and give that a value. And you'll notice that once we do that when we click a dimension, Live Rules is monitoring our modeling in Synchronous, and not only when we pull on faces but also when we change dimensions. So if I go ahead and scroll this to make it larger, you'll notice both sides are moving, and the reason for that is not the dimensions, but it finds symmetry about the coordinate system. So in this case we'll go ahead and leave it at 5 millimeters. And you can see that the front face is also quite thick, and we might want to monitor, or we might want to control that and make it the same as the other two side faces. So what I'm going to do is go ahead and lock that dimension, and then what we can do is we can actually edit the formula for the dimension and key in a formula, or we can just simply select a dimension value. In this case this is called linear 1, and make it equal to that. And you'll notice it changes it to a different color, letting you know that it's being driven by a formula. So now when I grab the 5 millimeters and I make a change, you notice that all sides change equally. So that's kind of what we're looking for here. And again, the 5 millimeters is good. So what I'm going to do is go ahead and turn off the PMI at this just for a few minutes, and let's go ahead and add some rounds on our part. I'm going to select the front corner, and I want that to be 3 millimeters. And so you notice that I can just easily select the edges in which I want to apply. It's going to give us a display of what that looks like. And I turn on the background components. You'll kind of see how this is going to start to take its role in this assembly. It's going to support the back part of this motor, so we need to build the bosses that support the end of the motor here. So what I'll do is I'll actually just grab the circle command, and you'll notice when I pass my cursor over the plane, it asks me, do I want to lock to that plane? Do I want to sketch on that plane? And I'm going to go ahead and lock to that plane. And when I do that, it shows you with the lock on the in the screen that it is locked to the plane. And then I can go to this sketch view, which kind of allows me to look at it like a 2D sketch if you want to draw that way. But in this case, I'm going to pick up the center point, and I'm just going to drag it out about, oh, say 20 millimeters. Once I place the circle, what I want to do then is I want to use the regions to pull out the actual protrusion. So I'm going to use a quick pick to select the first face, and then notice my cursor. If I hit the space bar, it puts me in this plus minus mode, and if I keep hitting it, it'll put me in plus only mode or minus mode. So it's really kind of cool. And what I want to do is I want to pick all 3 of these regions, and I want to simply pull it out 5 millimeters. I'm then going to draw one more circle. I'm going to lock to the circle plane. And if I just touch the edge, it's going to show me center, and I can pick up center very easily. And we're going to bring that out about 9 millimeters. And then I'm going to pick that region, and I'll pull it out 5 millimeters. So very quickly we can develop the pieces for this particular part. And then we want to round it. So I'm going to go ahead and make it, but I don't want it to be 3. Let's drop it back down to 2, and then we'll pick these other 2 edges just to get a nice rounded part. And you can see the part starting to take some shape. Now another area that we need to look at, you'll notice, is the part, this particular bracket here kind of comes through the side of our part. We'll have to take care of that. And also we still want to do a little bit of work in this area. So I'm going to go ahead and turn off the background components again using the Control Q, and then I can simply identify this the top edge of that face. And again, I want to go to multiple select, so I'm going to go ahead and hit my space bar, and then I can grab those 2 faces. Now at that point, I'm going to come over and I'm going to just extrude these 2 faces toward the back side. And you'll notice they kind of both follow with my cursor, so I'm going to just kind of go 6 millimeters. Then what I want to do is I want to rotate, and I want to make this a full circle in here, so I'm going to get that inside face, and I'm going to suspend live rules because I don't want them to take effect at this point. And I'm just going to pull this up, and I'm going to pick up the end point, and you can see how it closed off that circle for me very quickly. The next thing that I want to do is we actually need to thin wall this model out. And so I'm going to use the thin wall command. 1 millimeter is a good thickness, and basically quick bar prompts us for things that it's looking for. Do we want to leave any faces open? And we do. We want to leave this face open, obviously, so that the motor can go into there. But the one problem that I notice is when we thin wall it, it's also thin walling out these side walls. So basically what I'm going to do is go to a top view by doing a Control T, and then we can zoom out a little bit, and I'm going to take those out of the equation by just simply fence selecting them. That way they'll be removed from the thin wall feature. And then I can accept, and you'll notice it thin walls the model out for us very quickly. Now what we want to do is go ahead and turn our background components on, the assembly parts, and we need to take care of this interference here. Now in order to do that, in ST4 we've added the capability to to actually select faces of other components in the assembly. In other words, instead of picking the face off of the part I'm building, I can actually go to the faces on this particular component. These are the top faces of this bracket. And by accepting that, it automatically puts me in the extrude mode with the part that I'm building. One other cool thing is you'll notice down on the prompt bar down at the bottom that by using a space bar, I can either be adding material or hit the space bar and I could subtract material. So in this case, I'm just going to pull it down through and create the clearance for this particular bracket. Now the bracket does have a little L-shaped here, so it's fit pretty good. Now the other cool thing as well is because it's synchronous design, if I pick that bottom face, and I'm going to unsuspend my live rules, if I pick that bottom face, it's going to pick up coplanar, and you'll notice that it's going to add, and if I pull it all the way up, it's going to remove material. But I just want to come up about, let's say, 0.5 millimeters. That way we have the proper clearance above that face. Now obviously if you want, you could grab the side faces and move them out to give it a little bit more clearance if you need to do that. The next step in this process is to incorporate the part that it's connected to here. In order to do that, I'm simply going to use Interpark Copy on this part, and then I'm going to grab this face. And that's really all we need. Then I can Control Q to turn off those background components, and you'll see that it gives us that particular face. Now another thing that we want to do is draw a line. So I'm going to lock to this plane, and I'm just going to simply draw a vertical line on this side face, and I'm going to pull this out, and I'm going to bring it out 2 millimeters. Now that we've included this Interpark Copy, what I'm going to do is use the include command and lock to my back face and simply include these elements from this face that we've done an Interpark Copy on. And you'll notice that it creates a region for us. And from that region, we can very easily pull out, and I'm just going to pull it out 1 millimeter. And you'll see how that part that it connects to will fit right in there just by using that. Another thing that we want to do is go ahead and place a hole in here. So I'm going to grab the hole, and when we're placing a hole, we default to certain size. So what I'm going to do is I'm going to come up to the default settings, and I'm going to change that to a threaded hole. It's a millimeter hole, but it's only 3 millimeters. And we'll do to hole extent. And you can set up all types of different holes, and then you can save them as a configured hole so that they're easy to place the next time. We'll go ahead and click on the OK button. You'll notice it attaches the hole to my cursor. So no matter where I move, it's going to put that hole. What I want to do is I want to get it on center of that area there where the hole is from the included face. That way we know it's exactly in the right position. And when I turn that off, you can see that the hole was placed as it should have been. Very nice command. Now, one thing that we want to do is we want to replicate all of these features to the opposite side. And sure enough, I could easily go over there and actually do that, manually putting them in like I did here. But let's go ahead and just rotate, and I'm going to fence select this information. And then once I fence select it, what I can use is the selection manager by going to a face and picking on it and just saying, anything that's connected, and you notice it highlights that top face. So it's very easy to get into this selection manager mode, and then a spacebar takes you out of that mode and maintains your select set. So then what we can do is we can actually say, well, okay, what I want to do is I want to mirror this information, and I want to mirror it to the opposite side. And I just pick the XZ plane there, and you'll notice that it mirrored everything to the opposite side for us automatically. Again, very powerful command built right into Solid Edge, Selection Manager, and then being able to mirror that information. And now you can see how the part is starting to take some shape here. And what I'm going to do is I'm actually going to turn on selected edges and you get a little bit better idea, a little bit better outline of our part and how it fits into our design. Now, one thing that we want to do is we want to build a couple of boss tabs on this particular component. And what we can do with that is come over to our feature library, and under the feature library, which under our hand mixer you'll see feature library, I've got some saved features which you can do in Solid Edge. You can just create a feature and then you can drag and drop it into the feature library and use it in your design. So what I'm going to do is just simply drag this in, and you'll notice it attaches it to my cursor. So what I want to do is I'm going to actually put it on this top face and place it just on that top face right there, and then I'm going to use the steering wheel to move it into position. So by just selecting the primary axis on the steering wheel, I can move it out. And I'm not really concerned about how far it sticks out at this point. I'm just going to make sure that I just want to make sure it's off the front edge. So we'll just kind of place it in that area there, and you can kind of see there's a little bit of a gap right there. But the important thing here is to move the steering wheel to this top corner, and then what we can do is we can actually use the primary axis to, and let me go ahead and turn off one of the live rules there, coincident, and go ahead and pick up that top face so that we move that face down equal to the top of this part that we're building, and then I'm going to move it to the left and lock into that same corner. Now once that's done, I want one of these on the opposite side on the bottom, so I can just simply bring my steering wheel over to center, use the copy option, new in ST4, and then simply identify the torus and rotate this thing 180 degrees, and it's going to place it into our design. Now that our design is complete, you'll notice it created these face sets, and we can go ahead and we can just simply use the attach option. It'll attach that to the model, and I'm going to do the same for both. And very quickly we can bring in those features from our feature library and attach them. Now obviously we need to build the bosses, but we'll do that at a later time. Now one thing that's really kind of important once our model is built, and I'm going to go ahead and save this model, is that we want to maybe run an analysis on it. And in ST4, obviously simulation is built into our Solid Edge environment. We can run an analysis on this part. So what I'm going to do is I'm going to go to the Simulation tab, and before we do that, let's go ahead into the Properties, Material Properties, and let's apply a material. Let's say we're using aluminum 1060. And we'll apply that material to this particular model. Once that's done, it's going to turn the part to the aluminum 1060 that we've set, and then we can create a new study, and we're just going to do a tet mesh on this. Once we do that, all of the commands become available. For a force, I'm just going to apply it in this direction on that inside face where most of the pressure will be on this particular component. I'm going to apply a fixed relationship on the two back faces. And then what we can do is we can go ahead and run our mesh and solve. Now the cool thing about simulation in ST4, Solid Edge ST4, is that we've added some meshing options so that we can actually fine-tune the mesh. We do have the capability to mesh specifically to edges, to surfaces, or to entire bodies. So we do have several different meshing options, and some of those are new in ST4. We obviously support several different types of loads, and we also have different constraints, whether it's a fixed constraint or even user-defined. Now you can mesh your model at any time and you don't have to solve at the same time, but in this case we're just running the mesh and solve at the same time. I'm just using some default values. The cool thing about simulation built into Solid Edge is really built for the engineer. Not so much the guy that spends his living or his life doing an analysis, but more at the level of an engineer who wants to just run a quick analysis to make sure his part is strong enough for what it's going to be applied to in the assembly. So we're almost done. You can see it's processing the results. It should pop back in a second, and when it's done, it will take us into the results environment and show us the actual results from the simulation. And you can see from the results that where all of the stress is. We've got a little bit down here. Now, we didn't add any rounds, and that of course would strengthen this part. But there's a lot of things that you can do here. You can certainly run an animation on this, and it'll give you feedback as to how things are going to change. We can go to the color bar, and if we wanted, we could, let's say we take a look at the font. Maybe we change the font to black, and it kind of gives you a little bit better display of that. Maybe we set this to Arial. Maybe Arial black. And you'll notice that we can also turn on maximum, and it's going to show us where the maximum stress is in the model. We also have minimum markers. So there's a lot of information and things that you can do. You can change some different options for the display. If you want to turn on the undeformed model, you can do that. So in the results environment, you have a lot of control that the users can kind of get feedback. But in this case, it looks like our model is going to be plenty strong enough. So we can close that simulation out, and we can turn on our background components. And I think that kind of gives you a good idea of how synchronous design works and how easy it is to use, as Live Rules guides us through the process of as we're modeling our part. It kind of monitors the process and keeps the model intact. And then, of course, simulation, to be able to test our models, to check our models, to make sure that they're strong enough, determining on what type of analysis you want to do. So with that, this concludes the synchronous design and simulation portion of the demonstration.